Can artificial intelligence support sustainability without creating new harm? This explainer looks at the ethical implications of using artificial intelligence in sustainability, including principles, challenges, governance, societal impacts, and practical recommendations. The goal is responsible use that supports sustainability while protecting people, communities, and the environment. The ethical implications of artificial intelligence in sustainability include fairness, transparency, accountability, inclusivity, and long-term environmental and societal impacts. Ethical deployment matters because it helps foster trust. It also helps sustainability goals be pursued responsibly rather than at any cost. Fairness and inclusivity mean artificial intelligence should provide equitable benefits and avoid perpetuating bias or inequality. In sustainability, this matters when benefits could flow unevenly across groups. One example is making sure artificial intelligence-driven agricultural solutions help smallholder farmers as much as large-scale operators. Transparency and explainability mean artificial intelligence systems should be clear and understandable to stakeholders. When people can see how decisions are made, trust becomes easier to build. A source example is renewable energy grids, where models can explain how they make decisions about resource allocation. Accountability means developers and operators take responsibility for artificial intelligence outcomes, including unintended consequences. This principle matters because sustainable systems can still produce errors or harm. A clear example is using accountability frameworks for artificial intelligence in disaster management, so potential errors can be addressed. Environmental responsibility means artificial intelligence development should prioritize low energy use and sustainable practices. The aim is to reduce the environmental footprint of training and deployment. One example is using energy-efficient models to minimize the carbon footprint created by artificial intelligence systems. Artificial intelligence systems can perpetuate bias already present in training data or algorithms. A major ethical challenge is bias and inequality. Examples in the material include credit scoring models that exclude underserved communities and resource allocation systems that may favor wealthy regions because of biased historical data. Artificial intelligence relies on large amounts of data, so privacy and security become central concerns. The material highlights environmental monitoring systems collecting sensitive data on private lands or collecting private land data without owner consent. These issues can create mistrust, legal risk, and resistance to adoption. Limited access in developing regions may widen the global digital divide. The material gives precision farming as an example, where high costs can exclude small-scale farmers, making benefits less evenly shared across communities and regions. Artificial intelligence for sustainability can also create harm over time. The source notes job displacement, environmental degradation, and over-reliance on artificial intelligence in critical decisions. It also warns that biased systems influencing policy could perpetuate inequality, showing why long-term monitoring and human oversight matter. The ethics guidelines for trustworthy artificial intelligence emphasize human centricity, fairness, transparency, and environmental responsibility. Several frameworks and guidelines are presented for ethical artificial intelligence in sustainability. The material also names the Institute of Electrical and Electronics Engineers Global Initiative and the AI for People framework. Ethical artificial intelligence governance is described as essential for responsible, transparent, and equitable sustainability initiatives. Governance frameworks create rules, principles, and mechanisms for development, deployment, and oversight. Key features include transparency, accountability, and fairness, which guide how systems should behave and who is responsible. The material points to international guidance that supports more consistent ethical practice. It names the European Union Artificial Intelligence Act, the United Nations Educational, Scientific, and Cultural Organization Recommendation on the Ethics of Artificial Intelligence, and the Organization for Economic Cooperation and Development Principles on Artificial Intelligence. Governance becomes practical when organizations define ethical objectives, create oversight committees, and review systems for compliance. The material gives Microsoft as an example of using internal ethics boards. It also highlights audits, policy updates, and the IBM Artificial Intelligence Ethics Pledge to monitor fairness, explainability, and accountability. IBM Green Horizons is presented as a case study in ethical artificial intelligence for sustainability. Its ethical focus is transparent air quality prediction to support urban sustainability. By openly sharing artificial intelligence methodologies, it built trust among city planners and residents. Rainforest Connection is used to show how conservation work can be paired with ethical data use. The material says it ensures data privacy for communities while monitoring illegal logging. It is also described as collaborating with indigenous communities to monitor deforestation, helping align projects with local needs. 0504. The material says its systems reduce carbon emissions in data centers. Google DeepMind appears as an example of energy-efficient artificial intelligence in sustainability. It is also linked to demand for specialists in artificial intelligence and energy, showing how sustainability applications can affect employment as well as emissions. Artificial intelligence-driven sustainability initiatives can create both opportunity and disruption. The source highlights economic growth, new markets, and new roles in development, data analysis, and system maintenance. At the same time, automation in manufacturing and agriculture may reduce parts of the workforce and deepen economic inequality. Artificial intelligence can improve public policy through data-driven insights for resource allocation, urban planning, and disaster preparedness. Yet, the material also warns against excessive dependence on automated systems in critical decisions. If policy is shaped by biased systems, existing social inequalities may be reinforced rather than reduced. To minimize harm, the material recommends inclusive practices and community engagement. Representative datasets can reduce bias, while low-cost solutions can improve access in underrepresented regions. Involving local communities in design, implementation, and evaluation can build trust and better align projects with local values and needs. Involving local communities in design, implementation, and evaluation can build trust and better align projects with local values and needs. Involving local communities in design, implementation, and evaluation can build trust and better align projects with local values and needs. Best practice starts by embedding fairness, transparency, accountability, and inclusivity into system design from the outset. The material also recommends explainable systems for non-technical stakeholders, stakeholder engagement during project design, and regular ethical audits to check for bias, privacy issues, and compliance with standards. The recommendations bring the whole approach together. They include robust data governance with encryption, anonymization, secure storage, and consent, plus multi-stakeholder oversight, performance monitoring, ethical policies, energy-efficient development, carbon emissions tracking, education, training, and capacity building in underrepresented regions. Ethical artificial intelligence in sustainability depends on clear principles, strong governance, careful oversight, and attention to social impact. You have seen the main challenges, the frameworks that guide action, the case studies that illustrate practice, and the recommendations that support responsible deployment. Used this way, artificial intelligence can pursue sustainability with greater trust, fairness, and accountability.